Alright, so number 6, we've got y equals the natural log of the cosine of t over k. And it's important to really recognize that k right here is a number. So when I take its derivative, I'm going to treat it like it was t divided by 2 or t divided by 5, just a number. Okay, so y prime equals, outside function that we're dealing with is natural log. And d dx of the natural log of u is u prime over u. So we're going to want to take the derivative of u, which is this whole thing, and divide it by itself. The derivative of the cosine of t over k is negative sine of t over k times the derivative of t over k, which is just 1 over k. All divided by cosine of t over k. Okay, most likely, if you saw this on a multiple choice problem, the sine over cosine of t over k would be simplified. Since sine over cosine is just a tangent, you would see negative the tangent of t over k times 1 over k. So basically, we could just divide this whole thing by k. Okay, just to remind you why I'm saying the derivative of t over k is is 1 over k. If I was taking the derivative of x over 3, just like a plain old x over 3. This is the same thing as the derivative of 1/3 times x. And the derivative of a constant times x is just that constant. Okay, number 7. There's a trick here, as you might have guessed. Right here, when you take the cosine squared of a number plus the sine squared of that number, that is just 1. So this entire equation is really 1 over cosine squared, and 1 over cosine is the same thing as secant squared of x, minus the square root of 1. Alright, taking the derivative of this will be a lot easier. The derivative of the secant squared of x is the secant... That is not true. Wait 1 second. The derivative of secant squared of x is like taking the derivative of the secant of x squared. So we've got a little bit of a power rule there. Okay, so if we're going to take the derivative of the secant of x that is being squared, we actually need to use a power chain rule on it. We need to bring that 2 down in front, keep the inside the same, power 1 less, which is technically 1. Now times it by the derivative of that secant. And the derivative of the secant of something is the secant of that something times the tan of that something. Alright, and that something that the secant was being taken of x, we would technically be multiplying by the derivative of x, which is 1. The derivative of the negative root 1 is just 0 because it's constant. So if we wanted to clean this up a little bit, you can think of it as we've got a secant, so we have secant squared of x, and we've got tan of x. And that would be the answer there. Alright, moving on to number 8. We've got x cubed over 8 times 2 ln of x minus 1. And I think the way this is set up here, they really just want you to treat it like a product rule. You could actually distribute out this x cubed, but I guess you're still going to have a product, so product rule is probably the way to go here. Okay, so this is my u, and this is my v. So we're going to take x cubed over 8u times v prime, and the derivative of 2 times the natural log is 2, times the derivative of natural log, which is 1 over x, minus 0. So we're done with that. Plus v, that's 2 ln of x, times the derivative of x cubed over 8. Now, you are very welcome to treat this like a quotient rule, but that's kind of a lot of work considering one of the parts is a constant. So I'm going to think of it as 1/8 times x cubed, and the derivative of that will be 1/8 times 3x squared. Alright, putting it all together, it looks like that we have 2 and the 8, they're going to cancel, and that's going to become 1/4. So that's going to become a 4. And we've got an x up top and an x below, so this is going to become x squared, this x is going to go away. And so this first term will have x squared over 4. All right, and then this next term, a little bit more complicated and less to cancel. This 2 and this 8, once again, that becomes a fourth. There's no x's to cancel here, so it just looks like plus 3x squared ln of x over 4. And since they both have the same denominator, we could combine those two. All right, looking at number 9, we have cosine of t squared plus 3, which is just a whole function raised to the power 100. So we're going to want to use that power chain rule to get started. Y prime of t is going to be the derivative of some number to the 100 is 100 times that number to a power 1 less, which is 99, times the derivative of inside, right? So the derivative of the inside has its own outside and inside. The derivative of the cosine is negative sine, and we must leave the inside the same, times the derivative of that last inside part, which is actually 2t. So putting it all together, you could take that 2t, the negative, and the 100, and you could multiply those two to get all those three things together. So you get negative 200t. We have cosine of t squared plus 3 to the 99th power times sine of t squared plus 3. All right, finally, number 10. Theta here is a variable. And in case you're ever confused about whether or not it's a variable, just look right here. This is g of theta. That's your variable. So g prime of theta. We can treat this a couple of different ways. Personally, I think I would rather do something like, if this is 1 over the cosecant squared, that's the same thing as the sine squared of theta times theta. That theta is still up top. Okay, so now we've got a product rule. We've got theta times the derivative of sine squared. And the derivative of sine squared, this really is theta times the sine of theta squared. So it's a power rule. It's 2 sine of theta to the power 1 less, which is now 1, times the derivative of the sine, which is the cosine of theta, plus that second term, sine squared of theta, times the derivative of theta, which is just 1. All right, g prime of theta. It looks like 2. And technically, a lot of times in multiple choice answers, you will see this trig identity put in. And there is a trig identity that says that if you have the sine of 2x, it's equal to 2 sine x cosine of x. That's just a trig identity. So technically, this right here would be the theta times the sine of 2 theta. That's a trig identity. I don't need you to know that for tomorrow's test, but it's a good thing to know. Plus sine squared of theta.